Okay, hello everyone, welcome to this video. I'm going to start by going through a couple of the questions on the exercises 1C vectors sheet which you have, and I'm not going to go through all of them because quite a few of them are quite intuitive and you already have the numerical answers on the sheet. So I'm only going to go through a couple of the ones that I think are quite tricky, and hopefully this will be helpful. In question 2, you're given an inclined plane like this, and they tell you that this angle here is 30 degrees, and you have a car O, which is this car here, moving up the plane that way, and you're told that the weight of the car is 1000 newtons, and the frictional force down the plane is 100 newtons, and the force on the car due to the engine up the plane is 800 newtons. And they tell you the plane is AB, so this point here is marked as A and that point is B. There's several parts to the question. The first one, part A, asks you to calculate the component of the weight down the plane. So the way we do that with these questions is we want to know how much of this force here, which is the 1000 newtons, how much of that is along down the plane, so in this direction. So the way we do that is we say, first of all, we need to find a line using this force here, which is the one they give us and the one that we want to split up into components. We need to form a triangle with that, where one of the sides of the triangle is parallel to the side going down the slope. So we can do that down here. Doesn't matter where we draw the line as long as it's parallel. That's the good thing about vectors. And so this one really is the one we're being asked for in part A, which is the component of this 1000 that's going to go down in this direction, going down the slope. Right? Then the other component of the weight would be, we always split them at right angles, would be this one here, going into the slope, and we're going to use that later in the question. But these are the two components that add up, these two vectors add up to this longer hypotenuse, which is the real force. Always the two sides in which you split the real force are going to be smaller than the real force here. So, how do we find how big this side is? Well, we know that this one is 1000 newtons, so I'm going to write it down over here so that we don't confuse the sides. 1000 newtons is this side here, and I'm going to rub it off from over here, and this is what we're interested in, the weight down the slope. So that's not 100. 100 they told us it was the force of friction. So this weight of the car down the slope is really going to add to that 100 of friction, and those two together are going to provide the resistance forces against which this 800 newtons of driving force on the car needs to fight in order to move this upwards. The difference between those two forces can then provide us a resultant force, and we could even calculate things like acceleration using F equals ma, where F would be the difference between 800 and the combination of 100 plus the weight down the slope. But in part A they ask us for something quite a lot more simple. They just want us to calculate this side here, and to do that we need to know this angle here, because otherwise we can't do it. And we've talked about this a few times, that this angle is going to be the same as that angle, so that's also 30 degrees. So using SOHCAHTOA, we have the opposite, we're interested in the opposite side, and they give us the hypotenuse. So which one combines the opposite and the hypotenuse? So combines the opposite and the hypotenuse, so that the formula for the hypotenuse, so if we write it all out, it would be sine of 30, which is that angle, is equal to the opposite, which we're interested in, the weight of the slope, which is the opposite, divided by the hypotenuse, right, which is 1000. And since we're interested in that, we can multiply 1000 to the other side, and then we know that the weight, which is 1000 times sine of 30, is equal to the weight down the slope. Sine of 30 is 1/2. You can do it in your calculator if you want, but sine 30 you get to using it a lot. You get used to using it a lot, and it's just 1/2. So 1000 times 1/2 is the same as dividing 1000 by 2, and that's then our answer. Don't forget the units down the slope. So that's for part A. Part B asks for the resultant force on the car up the plane. So this thing is moving up the plane, they tell us, so there must be a resultant force acting up the plane, at least if it's accelerating it must be. And they tell us here to calculate the resultant, so we can assume that there is a resultant and there's still going to be an acceleration. So how do we calculate the resultant force? Well, like I said before, the 800 newtons are going to be pointing upwards, and downwards we have 100 newtons and the weight down the slope, so that's 500 newtons that we have to take away from the 800 because they're in the opposite direction, and another 100 newtons that we need to take away. So our resultant would then be 200 newtons up the slope. So that's what's going to provide the acceleration. And if we wanted to calculate how much the acceleration would be, we would say, okay, the resultant force acting on it after you subtract all the forces up and down the slope are 200. So then F equals ma would be 200 equals the mass of the car, which we are not told, but we know the weight is 1000, so the mass is going to be around that divided by 10, which is 100 kilos. A very light car. 100 for the mass, and the acceleration would be that. So then acceleration would be 200 divided by 100, and it would be just 2 meters per second squared. That's how fast it would be accelerating going upwards, given that we know that this is the resultant force. Okay, they don't ask us to calculate that, but I'm just doing it so you know that it can be done, and they could ask us to do it if they wanted. And in part C they say the reaction R on the car, which is this guy up here, that's the reaction. That's the force of the slope of the surface pushing on the car so that it doesn't go through the surface. They ask us to calculate the reaction on the car at right angles to the road. Yeah, so that's the road, and reaction is at right angles. If it is balanced with by a component of the weight in the opposite direction, OC. So in the diagram they tell us that this here is C, and the O is up there, so with this direction OC. So they tell us that the weight in the direction of OC is balanced by R, and they want us to calculate the value of R, the reaction. And that makes sense because it's not accelerating into the slope or upwards from the slope, so it must be that the forces going in and out are equal and opposite, because they don't provide a resultant force, they don't accelerate the object, so it must be in equilibrium. Not the same with this direction, because in this direction the forces are not the same, that's why it's speeding up even though it's going up the slope. So in this direction, if we want to find out R, we just need to know how much is the weight into the slope. So we want to find out this weight here, component weight into the slope, or perpendicular. Sometimes I draw like this for perpendicular. If you zoom in, it looks like this. Okay, perpendicular to the slope. Okay, so weight perpendicular equals this whole hypotenuse, the same argument as we used before for the sine, but now we've got adjacent and hypotenuse. So adjacent and hypotenuse is going to be adjacent and hypotenuse, so car toa. So we're going to use cos. So the weight on the bar would just be the full weight, which is 1000, times the cos of the angle of 30. And that comes out to be 866 newtons. Okay, and we check on the answer there, and it is 866, so we've done that one correctly. And we check the others, is 200, that's correct, and 500 for part A, that's fine. Okay, so hopefully that makes sense on how to do this question. And I'm going to stop now because I think I'm out of time. See you in the next video.